When graphing, g of x is equal to half x squared minus 10 and its parent function f of x is equal to x squared, the axis symmetry is x equals 0, since we do not have a b term. When substituting 0 into the function, we'll get g of 0 is equal to negative 10, which means our vertex is 0, negative 10. For my domain, I'll go in increments of 2, which causes our step pattern to be 2 times 1 times 3 times 5 times 7 times 9. Since our a term, our leading coefficient of this quadratic, is 1/2, our denominator 2, and our exponent is 1. We'll increase by 2 from negative 10. We'll increase by 6 from negative 8. We'll increase by 10 from negative 2. We'll increase by 14 from 8. For filling in my range for f of x, we'll just use mental math. I'm just plugging in. So therefore, all I'll do is plug in 2, and that will leave me with 2 squared is 4. Substitute 4, 4 squared is 16, and so forth. If I'm still having issues with using the step pattern, I could always plug in. And it's kind of always great to plug in your last term that you plugged in, just to check the step pattern, just in case you made a mistake. So therefore, I'll plug in g of x, x for 8. So what is g of 8? Well, 8 squared is 64. Half of 64 is 32, and 32 minus 10 is 22, leaving me with the 0.822, which checks out. When comparing the two graphs of g of x and f of x, notice first we have a vertical translation down 10 units. Now we could also see that graph g of x is wider, and this is done by this leading coefficient, 1/2. Remember, as a approaches 0, it will get wider. As a moves away from 0, it will get narrower. We will say if we have a vertical translation down 10 units and a vertical shrink by a scale factor of 1/2. Remember, we either have a vertical shrink or a vertical stretch. Those are the two terms. So if it becomes more narrow, we say it has a vertical stretch. If it becomes wider, we say it has a vertical shrink. Order the group of quadratic functions from widest to narrowest graph. Now we need to disregard the sign. Whether it's positive or negative, it doesn't matter. All we're trying to find out is which leading coefficient, which a term is closer to 0. And that would be b. 1/4 is the closest number to 0, followed by 1/2, then by 3/4. Remember, 3/4 is more than half a dollar. 3/4 of a dollar is more than half a dollar. Followed by f, which is 1, then followed by c, -2, and the most narrowest graph would be a. Determine whether a, the leading coefficient, is positive or negative. Find the coordinates of the vertex and determine whether it's a maximum or minimum point. Calculate the equation of the axis symmetry and find the coordinates of the x-intercepts. Since it's opening up, we know a is positive. Our vertex is located here, and the coordinates for that point is -2, -4. Remember, these are going in increments of 2. So a lot of people might want to write -1, -2. That's if you're just looking at the boxes. But notice, this would be 2 and then 4. So this is -2, -4, -6, -8. So this would be -2, and we're going down to 4. So -2, -4. Since the vertex is either the maximum or minimum point of the graph, we can see that this is the lowest point. Therefore, it is a minimum. The axis of symmetry is a vertical line that passes through the vertex, this line right here. The equation for this line is x equals -2. Our x-intercepts is where the graph crosses the x-axis, which are these 2 points here. Those coordinates are -4, 0, and 0, 0.